Now we are going to discuss under dynamic inventory problems under certainty. We are going to discuss the EOQ modeling with planned shortages. So this is an important issue, and because in many cases you have no other alternative but to go for planning for shortages. There are certain items, and if this is a feasible alternative, that means the planned shortage is a feasible alternative for the given item, how to determine the order quantity. Then we will refer to the numerical example, a typical numerical example we will go through, and then we will bring in the important issue called the quantity discount. And quantity discount essentially says that if the order quantity is more, why don't you you offer a unit price less, or the lesser unit price you offer. So this the whole concept is referred to as a quantity discount, and it is a well adopted policy everywhere in fact. So how to determine knowing the quantity discount scheme, and how to determine the order quantity for the given inventory item. So essentially the two important issues we are going to discuss during this lecture session. Now let us first explain that why the planned shortages may be a feasible alternative. Usually, the shortages should be avoided. That sort of the policy you must have, and whatever the inventory control systems you propose, we make sure there is the no shortage. But certain situations you can break this rule, but only in a specific case, and these specific cases are not that uncommon. Okay, so for certain items that are usually very expensive, like and for which there is high unit purchase price, there are many such items, like the fashion items like jewelry, dress materials, etc., etc. So today if you visit any the shopping plaza or the shopping mall, or for that matter any any market in any city, what you find, there are many kinds of items, and some of these items are essential, but many such items may not be considered essential under the consumer goods category or the consumer product category. I am not referring to the industrial product category. So mainly for the consumer the product category, you may find such cases, and even for the industrial say the product category, the shortages may occur, but you never plan for shortage for industrial say the product. So anyway, so if the item is very expensive, the shortages of such items may be planned in order to reduce inventory holding cost. So obviously the shortages cannot be 100% shortage, it may be 10% or 20%, and this the rules are followed, and obviously you make sure that even if there is shortage, there is only back ordering, not lost sales. So depending on the response of the customers, now this point is to be understood very clearly, because always when you go for the cost modeling for inventory item, there are two kinds of situations you come across, like particularly when you refer to the probabilistic model. Later on we will take it up. We will find that the shortage cost can be of two types. One is the back ordering cost, and the second one is the lost sales cost due to lost sales. So both are to be considered. So, and these two say uh, uh, say types of shortages are defined with respect to the response of the customers. The shortages or the stock out may result in either back orders, that means here the customers not withdrawing orders. It's not that essential, he may wait, is it okay, for another say even 2 months or 3 months, okay. But the shortages or the stock out may result in lost sales. That means customers withdrawing orders as the item's availability is to be assured at that point in time. Like medicines, you cannot wait. If suppose it's not available at a particular store, you have to go elsewhere to get it supplied, or the food items, is it okay, and other essential goods and products. So these are the two situations you come across. So here what we are assuming that the shortages can be planned for the back ordering case, and obviously the shortages you may plan in certain cases, but these cases are back ordering cases. Now, how to determine the order quantity? Let us first assume that Q is the order quantity or the lot size. S is the shortage quantity planned. That means another decision variable you have, that is how much the shortage is allowed. So this to be determined, and that notation is S. So here you have the two decision variables. One is the order quantity and the second one is the shortage quantity. T1 is the time when the inventory is on hand, that means it is available, there is no shortages. Whereas you come across a time period called is noted as T2, that means during this time period you face a situation called the shortage, is it okay. So the shortage condition prevails only during T2 time periods, and what you are assuming that the demand is known with certainty, that means there is a uniform demand. So, and what is small b? So we have added another the cost related term called small b, which is back ordering cost per unit per year, whereas we have already considered the small h. Small h is essentially the holding cost per unit per year, okay. So here for modeling this particular problem, what you need to do, that means you must have an estimate for the back ordering cost measured per unit basis and per year basis. When the lot of key units of the item is received, that means suppose at time t equals to t or t equals to 0. So you receive key units of item, okay. So and what you have that the order cycle starts. The customers whose orders are pending at time t equals to t or t equals to 0. Now these customers would be supplied their requirements immediately, and the maximum inventory is Q minus S. That means as soon as you get Q number of units in one shot, that means instantaneous replenishment. What you try to do, that there is a back ordering of S units. So immediately the S units, so the demand for S units will be met out of Q. So now you start the cycle with Q minus S. So this point we are trying to highlight. So how does your inventory profile look? So with planned shortages, the inventory profile looks like this one. That means at time t equals to 0 here, what you get? You get an amount of item Q, and this is the shortage amount. That means this part is the positive one, this is negative one. So the shortage means the negative inventory, and as soon as you get this Q unit, so you subtract S number of units as shortage. So you have Q minus S. So this actual the inventory level on hand will be Q minus S. Now you start consuming this item with a demand rate or the consumption rate as D, and you reach here. That means during this period you have a positive stock. That means this time period is T1 when the units are available, there is no shortage. But then beyond T1, what has happened, that you are getting these items, there is a demand, you are holding it, it's a back ordering situation. That means the demand remains even if you are unable to fulfill the demand, and during this time period, T2 time period, obviously this is the shortage. Is it okay? So what we are saying, that the T1 is the time period during which there is no shortage, whereas the T2 is the time period, okay, where the order cycle is T, okay, there is a shortage, and this it repeats, this cycle repeats. Is it okay? So this is the presentation of the inventory profile. So just to make a note that whenever you come across an inventory problem, so the first thing you need to do, that means the entire problem, the inventory problem, must be explained or must be represented by an inventory profile. So by looking at the inventory profile, and if it is correctly drawn, now the person concerned will understand that what is the major problem, what are the decision variables, and what are the assumptions underlying the modeling of the problem. Is it okay? So the construction or so the knowledge of inventory profile is a must. Okay, right? So now first, so you have the holding cost, you have the ordering cost, and you have also the back ordering cost. So while you get the expression for the total variable cost, so you need to consider the back ordering cost also. Is it okay? Along with the ordering cost and the holding cost. So let us first determine the holding cost. So the holding cost during the ordering cycle, that is ordering cycle is capital T. It consists of two parts, T1 and T2. So T1 plus T2 is equals to capital T. So during this ordering cycle, so Q minus S by 2, is it okay? There is a uniform demand. Obviously this is the average inventory, and H is the holding cost per unit per year. So obviously here you need to consider the time component. That means holding cost is possible, is valid only during this T1 time period. Okay, T1 time period. That's why the H is multiplied with T1. Now Q minus S is the demand rate. So how much time you require with this demand rate to consume Q minus S? That timing is T1, is a uniform demand. So and how long you take to consume capital Q number of units? Obviously you consume or you require now within capital T time period with a demand rate of the D, you consume or you use the entire the Q units. So Q is equals to capital T into D. Now we have Q minus S by Q is equals to T1 into D by T into D. That means what we are trying to do, that means we get the proportion Q minus S, that is T1 into D divided by Q. Q is equals to capital T into D. So we have an expression for T1 in terms of capital T, Q and S. So this is the expression. Now what you try to do, that means now you have the holding cost expressions. So here instead of writing T1, you substitute T1 with this expression. That means H into T, capital T, Q minus S by Q. So you have ultimately you have this expression, right? Next, what you do, now there are n number of order cycles per year. So obviously n into capital T equals to 1. Okay. So the 1 year the consisting of say n number of order cycles, and each order cycle is T time period, capital T time period. So n into T equals to 1 year. Annual holding cost will be Q minus S square by 2Q H into NT. So NT is equals to 1. So ultimately you have these expressions for the annual holding cost. Similarly, when you refer to the shortage cost, so that shortage cost is occurring, or the shortage does occur during the ordering cycle T, but only during T2 time period. So that's why the average shortage is S by 2. The B is the shortage cost or back ordering cost per unit per year, and here it is to be time corrected, and the corresponding time is small t2. So now you have small d is S by T2 equals to Q by capital T. Directly you get these expressions, and you have small t2 equals to Ts by Q. So this is the expression for the shortage cost per cycle. Is it okay? So instead of writing say T2 over here, you substitute T2 with Ts by Q. So you get this expression. So in the next step, what do? You calculate the annual shortage cost, and ultimately so you multiply it with capital N. So N into T is again is 1. So ultimately it is B into capital S square by twice Q. So the total variable cost expression is given by, this is the ordering cost. So it is the annual demand, that is Q D, and the Q is the ordering quantity, A is the ordering cost per order, like the same notations we have used in other expressions, and this is basically the annual holding cost, and this is the annual the shortages cost. So taking partial derivative of total variable cost expression with respect to Q and S, okay, and setting them to 0 as a necessary condition to satisfy, we get the following expressions for optimal order quantity Q star. We use these notations Q star and optimal shortages S star. That means these are planned shortages. So you have these two expressions. So please follow the steps. I have not written all the steps. I am sure that you will be able to get these expressions by taking partial derivative with respect to Q as well as with respect to S. So you will have two equations, and you solve these two simultaneous equations to get an expression for Q star as well as the S star. That means the optimal order quantity, and this is the optimal the planned shortage. So this is the expressions you get. Obviously S star depends on Q star with this particular factor as H divided by H plus B. So this is the simplified expressions. So you just try to get this simplified expression. So maximum interval say the level, that is M, is given by M equals to actually is a so actually it is the maximum, the difference between Q star and S star, that is M, and this is Q star minus S star equals to these expressions you have, and the total optimal variable cost also you can calculate, as this is the total optimal variable cost. Is it okay? So please try to derive these expressions. It's very simple. You have the general expressions for total variable cost. You substitute the values of say the Q and S, okay, or you substitute Q and S in the original expression with the Q star and S star. Is it okay? So you get these expressions final. Now these are two conclusions you draw. One is, if the back ordering cost is substantially greater than holding cost, order quantity Q approaches original EOQ. Is it okay? So this is one conclusion you draw. But if holding cost is substantially greater than B, the backordering quantity S is large. That means what you try to do, if this condition holds, you say almost the entire amount you keep as a backordering. You don't keep any stock. If the order arrives, or the order comes, or the customers approach you, so we wait for a specific time period, and then you go for you get the consolidated requirement, and then you activate your purchase action, and you get the consolidated requirements the supplied by outside suppliers. Okay, so that is the rule. Now here is an example. A dealer supplies you the following information with regard to a product dealt in by him: annual demand 10,000 units, ordering cost ₹10 per order, inventory carrying cost 20% of the value of inventory per year. It's considered to be high, and the price is ₹20 per unit. That is the unit price. The dealer is considering the possibility of allowing some back order, that means the stock out, to occur. He has estimated that the annual cost of back ordering will be 25% of the value of inventory. Is it okay? Whereas the holding cost is 20%, but the back ordering cost is 25%. What should be the optimal number of units of the product he should buy in one lot? What quantity of the product should be allowed to be back ordered, if any? Okay. What would be the maximum quantity of inventory at any time of the year? Would you recommend to allow back ordering? What is your opinion? If so, what would be the annual cost saving by adopting the policy of back ordering? Okay, so this is your say the questions, and you need to answer all these questions. So you have all these data. The D, A, H, then B. Okay. So this is in percentage 20% of 20. That means ₹4 per unit per year. This is 25% of ₹20. That means ₹5 per unit per year. Is it okay? In absolute term. Then you get the expression for Q star. You get the expressions for say Q star when back ordering is permitted. Is it okay? So this is your Q star expression, right? H plus B by B. An optimal quantity of the product to be back ordered, that is S star. That also we have this expression. So I use this expression. So 133 units. Is it okay? So this is basically the economic order quantity, right? When there is no back ordering, so that is the Q star. Whereas when back ordering is permitted, what is the expression for Q star and what is the expression for S star? So maximum inventory level, you can calculate the maximum inventory level, that is Q star minus S star. We have the expression, and we have the total cost expression when we use economic order quantity, that is this one. When you use say when you permit back ordering, so order quantity is 300, so corresponding total variable cost is this. And since the total cost with back ordering permitted is lower than when it is not permitted, the dealer should accept the proposal for back ordering. Is it okay? So here the cost is this one, whereas if you allow the back ordering, that means the cost has come down, and this the difference is substantial. So this will result in saving of this one, this minus this one, that means 894 minus 666, that means approximately 227 rupees per annum. Now the next one is, the important concept is quantity discount. In the original EOQ formula, what we have assumed that 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 unit price that remains same irrespective of the order quantity. Now, in the real world, what you find that there is a relationship between the order quantity and the unit price. That means in majority of the cases, if the order quantity is more, the unit price comes down. Whereas if the order quantity is less, so the say the unit price may be higher. Now, many a time what happens that if the order quantity is more, that means you are offered the quantity discount. That means the unit price will be substantially less. So, in many situations for a given item, a lower value of unit price is offered for order amounts exceeding some given quantity. Is it okay? The classical EOQ model assumes that the unit price remains same irrespective of the order size. However, in many instances this may not be the case, as a lower unit price may be quoted if the order is of a big size. So, this point already we have elaborated. Now, in this case of price discounts, the order quantity is to be determined. So, that is our question. So, if the price discount is offered, how to determine the order quantity, or whether you will opt for discount. So, if you opt for discount, what will be the order quantity? If you do not opt for the discount, price discount, what will be your order quantity? So, now what you need to do, you need to take into consideration the price levels for different quantity ranges. Okay. Now, there may be two situations: single price break or multiple price breaks. Okay. I'll just cite examples so that your understanding is good and the understanding will be appropriate. In a single price break, suppose the order quantity is less than 800. You are offered a price per unit rupees 10. But as soon as the order quantity becomes greater than 800, any amount, okay, from 800 to any amount, okay, theoretically speaking up to infinity. So, you are entitled to get a unit price of 9 only. So, this is referred to as single price break. Is it right? In general, this we are generalizing. If order quantity is less than Q1, Ci, that is the unit price for the ith item, is equals to Co. If order quantity is greater than or equals to Q1, then the unit price, the notation is Ci, becomes C1, where C1 is less than Co. That's it. Okay, so this is the generalization. So, this is a single price break situation. Whereas, in a multiple price break, just you refer to this particular table, what you find that the order quantity, if it is less than 300, that means the 299, 297, any value, okay, less than 300, the price is 10. If it is between 300 less than equals to, that means it is Q may be 300 but less than 600, then it is 9.5. So, this the prices are offered to you. If the order quantity is 600 and up to say less than 1000, that means say 999, price is this. So, same rule you follow, and ultimately you find if the order quantity is greater than or equals to 1500, that means 1500 or more, the price offered is 8.75 per unit. So, in general what you find that for the ith item, the unit price is C0 if Q is less than equals to Q1. The unit price is C1 if if capital Q is less than equals to Q1, between Q1 and Q2, Q2 excluded, and this process continues, and ultimately what you find that the unit price is C subscript n minus 1 when the order quantity is greater than or equals to say Q n, where C0 C1 is C0 is greater than C1, C1 is greater than C2, C2 is greater than C3, continuing like this, ultimately it is greater than Cn minus 1. So, this is referred to as the multiple price break. While determining the total cost in this case, as the unit price is a variable, the purchase cost may vary against an order quantity. So, this point is to be noted, and hence the total cost includes the purchase cost along with the ordering cost and inventory holding cost. When we will formulate the problem, this point will be made very clear. We need to determine the order quantity at a particular price so that the total cost is minimum. This is your objective. So, let us first consider a single price break situation, analytical approach to determine the order quantity. Okay, so we'll so both for the single price break as well as for say the multiple price break the situations, there could be two approaches to determine the order quantity. The first approach is we will always prefer the analytical approach, and if you get the solution through analytical approach, fine, no problem, that will be our preference. But if some reasons the analytical even if you apply analytical approach but getting a solution is a problem, then you will have to opt for alternatives, and the alternative could be a graphical method. So, both these approaches we will discuss in our the next lecture session. So, thank you.